I'm marking the first question. Let's see what is given here. A ladder having a length of 5 meter is resting against a wall, making an angle of 60 degree to it, having coefficient of friction as 0.3. Calculate the horizontal force required to be applied at bottom end to avoid slipping of ladder. Full stop. Weight of the ladder is 300 Newton and floor is smooth. See the condition given here that the floor is smooth. Now, based on this condition, we would be writing the data. We are into the first question on ladder friction. Here they have said that a ladder having length of 5 meter is resting against a wall. So first I would be drawing the diagram of the ladder. Here we have wall and floor. Ladder is resting against a wall and a floor, making an angle of 60 degree against the wall. So here I have angle 60 degree. The length of the ladder is given. Length is 5 meter. I can mark it as, since the weight of the ladder would be acting downwards, I will take this distance as half. That is, this 5 meter, I am dividing it into 2.5 and 2.5 meters. That will give me 2.5 meters on either side of the weight. So that becomes total length as 5 meters. Next, having coefficient of friction as 0.3. See, remember, here in these kind of problems on ladder friction, we would be having two values of coefficient of friction. First, they have given that a ladder having length of 5 meter is resting against a wall, making an angle of 60 degree to it, having coefficient of friction 0.3. So this coefficient of friction which they have given, it is between the ladder and the wall. So that is the value of mu w. So I can say that mu w is equal to 0.3. Next, calculate the horizontal force required to be applied at the bottom end to avoid slipping of ladder. See, if this ladder is slipping, ladder will try to go towards left, but we need to apply one force to the right at the bottom that will try to avoid the slipping of the ladder. And here they are saying that weight of the ladder is 300 Newton. W is given as 300 Newton. Now, I need to find out how much is this value of P, which will keep the ladder in contact with the wall. Because if the ladder is slipping, it will go on losing the contact and it would be moving towards left. So I need to calculate this rightward force. So how I would be getting this? First of all, we know that if we have a wall and ladder is resting against it, there would be reaction offered by the wall. I'll call it as RW, reaction offered by wall. Similarly, when the ladder will be slipping, it will be moving down the wall, and so I have friction force offered by the wall, that would be up. Similarly, if I see for the floor, they are saying that the floor is smooth. If the floor is smooth, then the coefficient of friction of the floor is 0. It doesn't have any friction. And if it doesn't have any friction, then even the value of friction force for the floor is 0. So here I'll call that, at the point where the load is applied, I'll call it as my point A, and this would be point B. So now we would go on for the calculation of load P. I'll say that solution, considering the ladder in limiting equilibrium, that is, it is just on the point of moving, and since it is just on the point of moving, I will say that the first condition which I would be using here is summation of fx is equal to 0, that is for the horizontal forces. If they are towards right, positive, and if they are towards left, negative. So here I can see P is towards left, so negative, RW is towards right, so positive. That's equal to 0. In other words, I have P is equal to reaction offered by the wall. I'll keep this as my equation 1. Then I would be taking the moments of all forces about point A. For that, I need to know the distances. I will extend this weight line and I need to calculate its distance from point A. This distance will be equal to, since here the angle is 60 and this is the hypotenuse, so I will say that if I want to find the opposite side, that would be sine theta will be equal to opposite side upon 2.5. Therefore, opposite side is equal to 2.5 sine theta. That is, here I have 2.5 sine 60. Next, I need to know the distance between RW and this connection between floor and wall. Now this distance would be equal to, this is my adjacent side and the total length is 5, so that will be 5 cos 60 degree. I hope you all have understood this. Now I would be taking the moments at point A. I'll say that taking moments of all forces about point A. Therefore, it would be called as summation of moments about A is equal to 0. Again, the condition of equilibrium. Here, clockwise moments, I will treat them as positive, and anti-clockwise moments, I'll keep them as negative. Therefore, if I see in this diagram, if at point A, the moment of P would be 0 because it is passing through A. Next, W, it is moving in anti-clockwise direction. So here I have minus W into 2.5 sine 60. Then after that, we have RW, which is acting in clockwise direction. Distance is 5 cos 60. So it is clockwise. So plus RW into 5 cos 60. Then we have frictional force, which is again going clockwise direction, and this distance will be equal to, it would be 5 sine 60, the total distance here. This would be, so it is FW into 5 sine 60, and FW can be written as mu W into RW sine, it is 5 sine 60, that's equal to 0. Therefore, I just need to calculate the value of reaction offered by wall. If we get the value of RW, we will keep it in equation number 1 and say that P has been calculated. So now I would be keeping this as W is given to me in the question 300. So minus 300 into 2.5 sine 60. This will be one term. I will take plus RW as common because that I want to calculate. In the bracket I have 5 cos 60 degree plus mu W, coefficient of friction of wall is 0.3 into 5 sin 60 is equal to 0. Therefore, I would be shifting this term onto the other side. I would be having this as this term which I am getting here. It is minus 649.52 plus RW into the value of this bracket is 3.799 is equal to 0. Therefore, I would be shifting this value onto the other side. So I have RW is equal to 649.52 divided by 3.799. So hence RW comes out to be 170.97 Newton. Now I will put this value of RW in equation 1 to get the answer of P. I'll say that put R suffix W in equation 1. Therefore equation 1, and it is P is equal to RW, and RW is 170.97 Newton. That's the answer. If we see in this question, they were telling us to calculate how much load should be applied at the bottom of this ladder to avoid the ladder from slipping, and that answer is 170.97 Newton load would be applied to avoid the slipping of this ladder. And with this we complete the question.